Europe builds, and it builds well.
We have the founders and the stories to prove it.
I'm Matilda Nathan, founder of Born,
And I'm Nikos Stathiou, journalist and author.
and together we'll be co-hosting some of Europe's greatest founders.
Join us as we unfold their stories with candor and detail. Hi all, and welcome back to another episode of Europe Builds. We have with us today Klajd Lika, CEO and founder of Bota Systems, a leading robotics company specializing in advanced force torque sensors for robotic applications. Founded in 2020 as a spin-off from ETH Zurich, one of the educational heartbeats of innovation in Europe, the company develops cutting-edge sensors that enable robots to perform highly dexterous and highly intelligent tasks across different industries. We're going to have a very interesting discussion with Klajd because Bota has managed to very successfully commercialize, expanded its portfolio and grown its presence in both Europe and the US, paving the way for new breakthroughs in both robotics and AI. So for all of this and more, Klajd, we're really excited to talk to you. Welcome to Europe Builds.
Thank you very much for having me, Nico and Matilda.
Welcome.
Welcome to Your Builds. So we always start by giving our speakers the chance to introduce themselves, the typical elevator pitch that I'm sure you've had to do a couple of times. So let's say in around 2 minutes, give us a summary of who you are and what Bota Systems actually does.
Of course, thank you very much. Although I didn't do so many elevator pitches, but primarily, diving deep into what we have to do. So for sure, I can give you a short summary of who I am and what we do with Bota Systems. So my name is Klajd, as you rightly pronounced, Klajd Lika. I am born in Albania, in Tirana in 1987, and I grew up in Greece. So I came in Greece when I was 6. I grew up here. I studied here in National Technical University of Athens as a mechanical engineer and with a focus into robotics right after. During my diploma thesis, I got a know-how on how to use a specific technology to build sensors for robotic applications. And this was in 2012, 13, approximately somewhere that period. And thereafter, I worked as a researcher for 3 years in National Technical University of Athens in the control system laboratory under the supervision of Evangelos Papadopoulos, that was our professor. He's still there now, and they're doing robotics. And at the same time, while working as a researcher for 3 years, I have been doing my own thing in parallel with the know-how that I got and the expertise that I gained during my diploma thesis to be able to build a new company that started since then. And as a project in 2016, though, I had to fly in Zurich. I came in ETH Zurich here. Now I'm located in Zurich, and joined the robotic system laboratory there from ETH Zurich with the goal and the ambition to commercialize the technology, because back at the day they wanted to use it for legged locomotion, for robots that they could walk, to be able to be stabilized and to be able to walk. That was the idea. It's a necessary technology that enables them. Thereafter, we saw that this has also a broader area of applications, and we continued on finding. I got some grants there, and then at some point, after 4 years, I spun out the company as an ETH spin-off together with my professor in Zurich, Marco Hutter and Ilias Patsiauras, the current CTO of the company, that he works also with me. And in 2020, it was during COVID, with aiming to revolutionize the world of robotic sensing and build the leading robotics OEM, sensing OEM. And today, we have quite some success in the market. Our sensors are used for applications like surgery, robotic surgery, like nuclear decommissioning, humanoid robots, warehouse automation, and whatever you can imagine that does robotics today. And modern robotics are enabled by this type of technology, this technology that we're building. And we so far have found a sweet spot on on making sure that these sensors are both easy to use by people, by integrators, by both OEM, original equipment manufacturers, if you want, that they want to build their own robot, and end users that they have no idea of robotics and they just want to use a piece of equipment to automate something. So our technology is a key enabler, a key sensing component of any modern robot that wants to interact with its environment. Yeah, that's more or less what we do.
Can I ask a follow-up question? Like you said before we hit record, that you're normally kind of going a lot deeper in this type of topics. I want you to explain what Bota does as if I'm a 5-year-old. How would you explain that?
That's quite hard though, but I could actually explain that as you are 5 years old. So imagine you have so what Bota does. Bota enables robotic applications to go out of cages. Robots now are dangerous machines that they are within cages. So when you use them in industrial environment, and we want them though, because they are useful tools, we want them to have them also outside and they to be around us in environments that we are also there. So in order for them to be safe, to be around and have some safety and be able to be sensitive, they need this type of sensing, and that's what we develop. That's our technology. We enable the robots to be outside of cages.
I
We
think
get
the
the
5-year-old. The 5-year-old is very excited about the world that's about to come through the applications you're going to unlock. I'm pretty sure.
And just can I ask a follow-up question? And what differentiates you from kind of other people are doing similar sensors?
No, and there is similar technologies, but not the same sensors. Similar, maybe there are some, but what makes us unique is that we have managed to put everything in one small device. Everything, all the electronics, we have tightly integrated everything, and they're extremely easy to use. So we have built some layers of software for that people can use from, as I told you before, from the robotic builder, that's very highly specialized one, up to the point that someone just needs to take this device as it is, as one device, place it under a robot, screw it with, with a normal screwdriver, plug it in the cable, and open up his laptop and start working directly without, special knowledge of robot sensing.
This is something that you started as a spin-off from a university. Now, for better or worse, sometimes we have this idea of education being removed from the market, focusing more on the innovation front. So I'm really curious to ask you, how was your personal shift from academia and research to starting your own robotics company? What prompted this, and whether there were any challenges or new ways of thinking you had to unlock to go from, say, like a research perspective to go-to-market perspective?
Yeah, that's quite a question, I think, and it's necessary for many engineers that they want to become entrepreneurs to understand a little bit, and it's better sharing sometimes. So for me, was not exactly a researcher, but I was primarily looking on how when I was doing the force torque sensors. Not the other research, because it was also other research back in the days, but for force torque sensing in my business, I was getting the feedback from the customers that we had, and I was trying to incorporate this inside the technology that we have been building. So although it began as something that was about doing something fancy, a walking robot back in 2012, got this technologies, know how to build something, and this was like my engineering thing. I built something cool. Now how can I sell it? But this is not exactly how business works. So business works a little bit like the other way around. So there is a need somewhere, and then you have to build this thing for this need there. So it's about identifying this need or this market fit, if you want. Market fit is also a term that you use when you have a technology you want to fit it in the market. But I think a better way to describe it is like there is a need by someone, and then you develop this thing for someone. And in the beginning, I was the customer of myself, so I needed this thing to be able to work with it, and I developed it around that. And then I knew how my customer would think, and by talking with them all the time, what new features you would like, and so on. Then you switch a little bit modes from someone that is like technology driven, so you try to push the technology somewhere, but maybe there is no market for it, to someone that actually has a know-how and possesses and has an expertise in house, uh, and build something for someone. This is a little bit of, you have to make sure that you switch this thing, because when you study engineering, it's very tricky to just build things for yourself.
And did you notice that when you went to ETH that they helped you frame or kind of develop that thinking, or you feel like throughout kind of Europe, engineers have a similar mindset before they go out and start commercializing the idea?
To switch the thinking, you mean about from
The thinking as in like you're not building for yourself. It's actually you could actually build for starting from the customer's needs.
There are many reasons why people can switch and can understand. Maybe there are some books that you read during your how to become an entrepreneur, or how to, I don't know. There are a couple of books that you read. Sometimes people educate themselves. Sometimes it's a market itself that gives you, like the feedback, and this feedback you put it there and you say, oh, look, I did something the last year and I don't know what to do with it now. So I spent 1 year of doing something that's not needed. So then you learn that you shouldn't do that again. So at the same time, though, there are people out there, good willing people, that they want to help you. And for example, that may be some ETH, let's say, organizations or small or people that they help to do this transfer. It's called ETH transfer, and they support you into making sure that you get also some courses. Make sure that you understand a little bit also how entrepreneurship work, what is a startup, and how to transfer technology from academia to business, to the market.
Makes sense. And it's actually good to see that you like universities do offer kind of this commercialization framework or path. So I just want to take us a tiny bit back and kind of get into Klajd's mind. I would love to understand how you think. So I would love for you to kind of walk me through one of the key moments, pivotal moments of Bota Systems' life, and kind of
Oof.
how you thought about solving a problem or make a decision that would take you one direction or the other.
How do you think? The train of thoughts. It's difficult to say, actually, because it has been many, many years, and a lot of things that have been going through, and many ups and downs back in the days to go from one place to another. And we had quite some difficult times. I don't think there is a startup out there that has not seen difficult times, that you actually go through hardships, but you have to overcome them, because otherwise, if you don't, like, the startup is going to fail. So you have to be a little bit of like a protector of the child that you have been trying to do. So for us, the way we shaped it, I think in my mind was that, okay, now I have something, I try to understand, because when you are in a university, you're a bit protected as well. When you go out there in the market, then you're not protected anymore, and you have to make sure that. So you have to actually go by yourself, ask for money, for funding, for whatever else. For customers is the most important. So for us, we needed to make sure that we don't create another startup and we just burn money. And we start and see if we could bootstrap this. And if you show that you could do that and you can sell, then this is, if you want to accelerate, then the acceleration comes on top of that. So in our case, it was like we started to sell the sensors to different and the technology to different institutions out there and companies. And thereafter, we wanted to accelerate, and that's why we actually decided at the same time to grab some funding and to accelerate our push to the market. That is one thing. Now, Yeah, if you could be a little bit more specific, what you want to know would be nice.
So let's take a moment in commercialization, as it's like a hot topic, especially in robotics. And I believe like you have already quite a few clients, and you've kind of done the step from concept to actualization. Um, how did you approach commercialization in the very beginning, and how's this developed over time?
The commercialization. So, I mean, like you have a prototype usually. So when you're in a lab, you have some prototypes or some minimum viable products that they work 90% of the times, and the rest 10% of the times it don't work. So maybe you stay down for 10 hours to rebuild it and to fix it, but this is not sustainable. If you want to commercialize at the same time, you have to make sure that you have uh, an ecosystem in place that actually, not an ecosystem, but a process. Let's put the process in place that you develop something, you minimize the waste of manufacturing, and at the same time, while having customers in place that give you feedback all the time. And in order to have also customers, you need to have your documentation. You need to have, the necessary what's called necessary certifications, the necessary supply chain management that you need, the necessary stock, the safety thing. So these are not to be taken lightly. I would say 80% of the work can be done, through a prototype. It's a little bit also the Pareto principle there. So 80% of the work can be done in the prototype level with 20% of the effort, and the rest 20% needs 80% of the effort. It's a hard thing to go to the actual commercialize, because when you commercialize, when you actually get something you sell something, someone pays for it. What happens is that this guy has, he's going to come back to you if he has a problem. You just cannot really give something out there and just close your phone. I mean, you're gonna or not respond to this customer. You have to make sure that
You're responsible. You
you're
take that.
responsible, yes, and accountable for the technology that you give out there. So there are many factors to see in the commercialization.
There could be many fields that the sensor could be useful for. Like you said, like medical procedures, or you said like manufacturing. How did you make that selection of, okay, where do I go first? How do I approach this problem?
So we had an organic, let's say, way of approaching our customers. We didn't go straight forward. We actually had the technology. We showed some demonstration of where it can be used, uploaded on our website. We did a very good job in SEO optimizing and making sure that this is spread around there, or also through fairs. So we showed through fairs what this can be used to. And then the customers came to us and they asked that I want this and that. Although there was already some history about who is using this type of technology, who would like to use. So we developed not totally arbitrarily, the applications, but we had an early indication of where this can be used. So that's how we started developing the first demonstrations and uploaded the first videos on our website, on our YouTube channel, pushed it through through LinkedIn or other social media. Yeah, that's how we got a little bit of an indication of what the market looks like for us organically.
I have an interesting follow up that came to mind when you were talking before too about the wide spectrum of applications that this can have, right? So when you specialize in these sensors that could be used in so many different contexts, how does this affect how you build the prototype? I'm assuming the specific qualifications of tasks of dexterity that a robot should perform in an industrial context is very different than in a medical context. So how do you build something that is flexible enough that it could sort of go to all these different directions?
So I mean, like from scratch, from the beginning, this is enabling technology. So it was built. The principle is patented. So we have something that's scalable. So we can customize it for any customer. And this just put a click on your design software and or a multiplication factor, and you have bigger or smaller sensor. It's parameterized. So you do that this way. Now we have also some customers, because we have a portfolio that are off the shelf. That's what we sell primarily, and this is organic sell. We don't do any additional engineering. The additional engineering that we do nowadays is primarily for big customers that they want to have something customized, something to fit tightly in their own robot.
I was just going to say, is Kinova one of these examples?
Yes. I mean, we did some customization there, yes, but not for the sensor itself. Some around work, so some auxiliary devices that we did. And we have also with Kinova, we just launched a partnership. So we are partnered together. They can distribute our sensors to their channels at the moment. So this is going well there. But we have some customers that you don't see our sensor outside, so it's tightly integrated within.
Okay. So it's not visible that your guys are doing it.
No.
I'm curious about this partnership with Kinova. Do you want to tell us a little bit more about how it was forged and what was sort of the thinking behind this from your side as well?
We have many years that we've been working with them, and with this type of robot, because we have been using the lab. It's one of the best robots, most lightweight robots to use at the moment. They have also some certifications that regarding medical devices, and they are very active into medical industry at the moment. And with Kinova, I mean, like we have been. It's a company in Canada. It's located in Canada. They do have some haptic feedback on their end, but we enhance it with our more precise, haptic feedback with our technology. And there are many customers that in the beginning, they started coming to us because they were looking for something more sensitive. We had it, we had the robot itself, and we had some demonstration of it. And people, when they saw it, they said, okay, I mean, like either through whatever channel we had it, they wanted it because they wanted, to have this type of sensitivity, And then, I mean, like this triggered also the guys from there, and they really liked what we're doing. So it's a joint it's a collaboration, let's say. So we push also on our end, their robot for applications that we receive from customers, and they're gonna push also on their side, for our sensors at the moment, for our technology. And now they are distributors of ours, and they can sell directly to their customers our sensors.
Are you proactively going after these type of partnerships in other industries, or it was kind of not part of your go-to-market strategy?
No, it was. We do proactively. We see what and where our sensing technology has, its USPs.
Mm-hmm.
And this is where we focus to develop something. So if we have something totally very lightweight, we try to find the partner that has also lightweight applications, and we actually go to them for the go-to-market. So we search for the users that have been using this, and we target our marketing there. And also, the development a little bit about that, the auxiliary devices and the kits that we develop for them.
One last question before kind of we move on to the next topic, but I'm very curious of whether, like within the robotics kind of sphere, you have do you have a sales department, or you're expecting your engineers to actually sell the technology?
Yeah, this is quite a topic, right? I mean, like we have sales department that takes care more of the soft sales, more of the not the administration part of it, if you want. But we train also when we go for fairs, for example. We as engineers go there as well, and we sell it because we talk with engineers as well. So it's much easier. You avoid, this back and forth. It's much more efficient. Our guys to sell, the engineers, the developers to sell what they have developed. So we have this thing in house that we make sure whenever something new is needed, people know why they're developing it, for whom they're developing it, and how they can sell it. How they can sell it is another story, but they know to whom. And when they are in contact with the customer, when we have contacts from customers, we redirect easily to them, or we are in joint meetings and we just discuss all of us together. I mean, like how we could potentially bring the best value out of it.
So the engineers are engaged in that
Yeah, of course,
process as well. It's super interesting.
Of course, always. It's super hard. I mean, like to find people that they are from sales that they to sell there, but to sell our products. It's difficult to go through that, but it can be done with special training. But it's much more efficient. If you want to hire sales guys, salespeople, or marketing, you have to really go through thorough training. But sometimes it's much more efficient to turn an engineer that has already a tendency to go that direction to become, this type of people.
We hear a lot about robotics and AI. It's a rapidly evolving industry, right? What are some of the future applications that you are most excited about and you see as the most promising as a trend, let's say, in the future, in the next 5 years?
In the next 5 years,
Yeah.
we're going to be happening.
Yeah.
I quite like, the underwater robotics, to be honest. Underwater, for instead of sending divers to perform underwater jobs, to do welding or to do cleaning of vessels and ships and so on, or for maintenance. And this is quite a good field to do some robotics there, because it's a dangerous job and it's gonna become fun job if you have a robot to send there and to teleoperate it.
Super interesting.
It's like a game, that you're trying to clean something and so on. This is quite nice. In the next 5 years, though, one other thing that to me it's still a question is the humanoid robots.
Yeah.
And it's still a question, though, if they're going to be around us in houses or not. They're going to be for pilot projects, but restricted use cases. That's what I see, and I would love to see. At the same time, we see a lot of robotics in warehouse automation, to make sure that the processes within logistics is fast. And so if you order something from a logistics company, from an e-commerce company, it comes to your door in 40 minutes. I was, just to say an example now, I was, an example not of robotics, but what I experienced when I was in San Francisco, because this before I didn't have it, I didn't see it before. I was about to go for a meeting, and I was staying at my sister's because my sister lives there, and I was actually having I needed to have a shirt. The shirt was cleaned, but it was not ironed. And then I asked my sister, "Hey, do you have irons?" She said, "No, we don't use irons." I said, "Oh, no, you know what I'm going to do, blah, blah, blah." And then she said, like, "No worries, I can order." "No, but my meeting is 2 hours. What do you mean you're going to order?" I said, no worries. And then, she ordered, and the iron came in 40 minutes. It's incredible. She ordered online, and the iron came in 40 minutes. Could you imagine, the whole process that this goes through? So she gave the order online. It went to the central, logistics center. So which one is available? Where is in stock? People went there, the whole process, and then someone went and picked it up, from the warehouse, from the specific spot that this iron was, took it out, went on the bike or whatever, and came to our house within 40 minutes. And that was like, wow, okay, that's incredible. And I just see, this happening with robots quite faster. So that's what robots are going to do. They're going to bring this time, this 40 minutes to 20 minutes. And that's what the quality of the services that these companies are going to provide if they have robotics in place.
Can I ask a follow-up on this, which is, what are kind of the hardest problems you need to solve in order to be able to actually go from make humanoids work, or go further, in your example, from 40 minutes to 20 minutes delivery from a technological standpoint?
So humanoids now, today, have been building humanoids, people, since 40 years.
For many years.
It's not a new thing. What's new is some technology advancements like batteries that enable them to be more autonomous, more hours working. Actuator technology also became a little bit more advanced, so they can handle more torque. Also, sensing technology is much more robust, and the processing power behind it, the computers that they have on board, they are also very powerful to be able to compute all the sensing information, whatever comes from the sensors, and calculate what they need to apply as to the robot itself to walk, to do. So I think what has changed is the fact that we have much more advanced hardware, but what is going to make the change, a lot of change, is the AI behind it, the way to control these robots, to reason, the way these robots are going to reason, the way these robots are going to plan the steps ahead, and the way they are going to be reactive to their environment, so the sensing itself and the processing power behind it. So we see quite a lot of companies that they build today, I mean, humanoid robots, and I think there are going to be many more coming. We have already received a couple of customers that they are now building their own humanoid robots. But what is really going to say if this is going to be reality or not in the next 5 or 10 years is how well and how well we're going to advance, the control of these robots. Many people have placed their bets on building robotic foundation models or robotic AI in physical AI. So to build a brain that could potentially control these systems, this hardware, and I think that this is going to be the breakthrough there. I mean, like if someone finds a way, we're working on that. I mean, like the whole community. So we have single purpose, humanoids at the moment. A human that can go and fetch something.
Yeah, like I was in LA and like there are these small robots that go around to deliver food.
Yeah, we have this.
Mhm.
We have this for single purpose, and that's, I think, the way that's going to be done. So one by one, and then someone is going to come and they put them together, and we're going to have them as options. So today you are, I don't know, like a delivery robot. Today you pick up, the clothes. Tomorrow you wash the dishes. I don't know, or you bring the food. So we're going to have this, and I think for that reason also we are building this sensor, so they are able, these robots, to interact with the environment, picking up objects, putting them together, or I don't know, like assembling them, or cutting food, or all these things together. But we have to make sure that at the same time we do that by being safe around the robots, by making machines that they're safe to interact with. And safe, I don't mean in terms of that the AI is gonna go nuts and it's gonna do whatever it wants, because this is science fiction more than anything else. But I'm primarily saying about the fact that this is a metal part. If the battery falls down, if we don't have the controls there, or the communication, or the reason behind it quite well done, then it's gonna fall down. And it's like, I don't know, 40 kilos, 50 kilos, or whatever, and it's gonna fall on your what's called, on your leg, and it's gonna break probably something, or it's gonna damage a little bit. That's what can happen. Or it's gonna be, I don't know, like picking up a plate and just a dish, and this by accident it breaks. I don't know, something else is.
Crack. Mm-hmm.
Yeah.
Yes, and then it can fall on your leg. This can happen, but not about the robot going nuts. We just have to make sure, the same way we have a car today, and by going in the car, when we ignite inside, our engine, there's a lot of heat being produced in there. This is like a bomb car, if you think about it. We have
And you test all these precautions, etc., like to test it against all these
Yes.
different
So you have
scenarios,
all
right?
the
Yeah.
regulations. You have the coke in place. The what's called the regulation, the road regulations, the traffic regulations, I would say. Because with the car, we're moving at 1-ton machine with speeds of, I don't know, like 50 kilometers per hour, 100
Yeah.
kilometers per hour. And this is quite dangerous. I mean, like compared to what a robot can do if it can fall on your leg. But we are quite aware, we're quite educated on using them. And same thing should and will be happening in robotics as well.
You
And there can
mentioned
be also regulations and educations and everything.
you mentioned regulation, which is a very European word, I would say. So it's kind of a segue into something I wanted to ask you, relating to the two markets, right? So you serve clients in both Europe and in the US. Matt mentioned before, in LA, you see these robots sort of even serving coffee or doing these small tasks, right? We don't necessarily see that same level of adoption in a lot of places in Europe. So I'm wondering, from your perspective, how do you see these two markets differ in terms of the demand and in terms of the adoption of these robotics technologies. So what's your take on like the two markets and how they differ?
In Europe, in general, we're a bit like more conservative, I think, compared to the US market. They are, easier, faster adopter, and they are willing to risk a little bit more to get something more. Whereas in Europe, we're a bit like different. So in there, like the innovation is welcome most of the time. So you can have, especially in places like the Bay Area, the San Francisco, California, and and the East Coast, you see all this adoption there for robots as well, as you said. In Europe, it's a bit harder, I would say. And as you said, it's like a European ward, the regulations. But it's there is difference. There is quite some difference, I would say. And here we need a little bit, I think, both ways though. The US cannot be totally, I think, reckless. The mentality there and just do whatever we want, and then we learn by trying. So we first people are killed, and then we fix things. Here we try to become a bit more proactive. In Europe, people are trying to become, so that's why the regulations come first here. And I think both sides should come a little bit like in the middle. So also in US now, I've been to a couple of forums in US that they were discussing about safety and regulations. They were also mentioning that, in US people are complaining that they don't have regulations. Well, in Europe, have done a very good thing that they have regulations. And then I come in Europe and I hear the other way around, vice versa of this thing. And in the US, they don't have, and they are easy to innovate and whatever happens. And here we are all day with regulations. So I think it's both ways. You can see all different perspectives there.
Yeah, I think, of course, like the US have been definitely less risk averse for sure. So judging by the result, actually. Now, in robotics and kind of uses of AI, maybe kind of the type of regulation that Europe is trying to push forward, maybe it makes more sense than other fields. But I was actually curious when, like, you're European, that you live between the US and Europe, like how has your European identity helped you or not when you kind of went abroad and when you're selling abroad?
Yeah, how it can help. It's like this thing is like customer advice from US. I think if I could be in my customer's shoes, if I could be an US customer, I would think like, okay, if I want to buy something robust, something that works, I'm gonna buy something from Switzerland, Germany, and so on in Europe. Also in US, but it's more likely that these things, are reliable for long term. That's one thing that gives you a little bit of an advantage if you have a European thing. I mean, you are more likely to have something it may be a little bit old technology, but it works for sure.
Mhm.
So that gives you an advantage. And while being in Switzerland, though, which is a bit like different from from EU in a sense. In Zurich, in general, it's like a place where people are from all over the world, and there is quite some reputation about innovation in US as well about Zurich. So they expect to see also an innovative part in what we're selling. Not only the thing that's reliable, but they see also innovation. So it helps a lot to have both things, these two things together.
Amazing. Very, very insightful conversation. I would like to close this with a question that we've started asking the people we're interviewing, which is what are you mostly afraid of? Are you more afraid of success or failure? And kind of a bit of flavor why.
Ooh,
We take it philosophical at the end.
Yeah.
Okay. If you're more afraid of success or failure. So just to answer your question a little bit, like what is success and what's failure? So we can actually dive a little bit deeper. What's success and what's failure? I mean,
That your company actually is adopted by the whole of the robotics and like the whole, like all industries. So you become a billion-dollar company, let's say.
I mean, we can always say what you're more excited about, success or failure. if you would like to think a little bit about different in that way, because we shouldn't have fear, I think, as a thing in our vocabulary at all. We should know that it is there, but I think it's better to think in terms of positivity and in terms of what you're excited about. It gives you a better perspective, I think. And I'm more excited about success, to be honest. And if there is failure there, I'm also excited, because in the end, I'm gonna have learned a very good lesson. So both ways are win-win. It's a win-win situation, anyways.
He basically he basically flipped fear to excitement. So I guess it's a very good response. A very good way to end this episode as well. Thank you so much, Klajd.
Thank you very
Also,
much.
you gave us so much to digest, from linking the academia to go to market, and from talking about successful commercialization, all the interesting applications you see robotics going into in the future, and a lot of interesting insights into Europe versus US. So thank you so much for sharing all of that with us
Thank
today.
you too.
Thank you for joining us for another episode of Europe Builds, where we show that the European ecosystem is no longer an underdog story.
If you like our episode and want to hear more, follow Europe Builds on Spotify, Apple Podcasts, and Born's YouTube channel.